the stars tend to get made in clusters, in groups. The reason for this is that a given cloud will fragment into multiple pieces, because you've seen them. They're not spherically symmetric homogeneous. They have this complicated geometry with many little dense knots. Each of those can give rise to a star. And so more or less all of them will kind of do their thing simultaneously. And however many those dense cores you have, that's how many stars you're going to make. And then as soon as the big stars start shining, game over. So star formation is self-regulating because these stars last millions of years, and collapse process is 500,000 years or something. That means that there'll be regulation. Once you start making stars, you can't make new stars until those massive ones are gone, and then you can start making more stars. Well, so radiation is one thing. They ionize the gas. The second thing is they like to explode. And what that does, in addition to photoelectric, to photoionization, is there is sheer kinetic energy that's been implanted now in that gas cloud. That's approximately 10 to the 51 ergs for a typical supernova. And a shock wave just clears out the dust, sweeps it out. And so this is where those bubbles you've seen in pictures of interstellar medium came from, right? But they begin like this. And so the moment first supernova goes off in your star-forming regions, that's it. So stars eat clouds first. They're made out of that material, and then once they're made, they just destroy the rest. And you can also have a shock wave from explosions. So this is a cartoon, what that might look like, and this is an actual picture of one such thing taken with Hubble. So we have a pretty good idea how stars form. Now, stars do something else interesting and important, and that's highly relevant for formation of planets, which is stuff falls in, settles into a protostar. But if there is any angular momentum, that angular momentum cannot be radiated away. So the material which had excess angular momentum has to settle into the lowest energy state for a given amount of angular momentum. And as you'll probably recall, when we were talking about the origin of Kepler's laws, that essentially means circles. And so material with too much angular momentum will settle into a thin disk around newly minted star, which is made out of stuff we didn't have much angular momentum. And this is artist conception, but we actually have seen real things. Oops. Here we go. And these are obtained with Hubble in the Orion star-forming complex. And they're not necessarily symmetric, but they really are little protostellar disks with young stars embedded in them. Another thing that they do is they drive so-called bipolar outflow. If there is any magnetic field, and usually there is some, inside of that protostellar cloud, as it collapses, it will get bunched up and threaded through this disk. The disk will keep spinning and tightening it even more. That creates a preferred